Assalamu alaikum warahmatullahi wabarakatuh, students. Welcome to my YouTube channel. We have started our YouTube channel, and in the previous video I just went through the introduction of inverse trigonometric function, where I defined some basic concepts like conversion of degrees into radians, and we went through the sine inverse function. We went through sine function and from that we found the inverse of it, that is sine inverse x. Now the second one is cosine function. Cosine function we will be dealing with it, and from this we will find its inverse, that's cos inverse x. Here the cos function, it's defined as the cos function y is equal to cos x is many one identity function. Students, we have to just look into the matter that how we are able to find the inverses. It's only possible when we restrict the domains and make the function 1 1 and onto. Only after that we are able to find the inverse of that function. Similarly here it's many one and into function. As in the previous video I defined what's many one and into, so you'll be understanding it quite easily. Its domain is the set of all real numbers and range is -1 to 1. Set of all real numbers is its domain, and but the range is only -1 and 1. That means it's many one but it's into function. You have read that what's many one and into. Now students, what we have to do, we have to do certain restrictions by virtue of which we will be able to restrict the domain and codomain, and we will be able to find the inverse of the function. Simple. But here we will what we will be doing is we will restrict the domain of cos function to 0 to pi, then it becomes 1 1 and onto with range that is also here -1 and 1. What we are doing here, we are restricting the domain to 0 to pi, or actually we can restrict the domain in any interval of -pi to 0. It can be 0 to pi, or it can be pi to 2 pi, so that it becomes bijective with range as -1 to 1. Now what's bijective function? I will be showing you. Bijective function is that function which is both 1 1 and onto. I have told students that to understand this chapter very effectively, you have to make your strong hold on relations and functions. Still I will be helping you in certain simple concepts. Here bijective function comes. A function f from a to b is said to be bijective if it's both 1 1 and onto. If it's both 1 1 and onto. Now you will be knowing what is 1 1 and onto function. 1 1 function is also called injective function. It is defined as a function from f it's from a to b, where distinct elements in set A have distinct image in set B. You just look at the example. 1 1 function. 1 1 function is like this. Here in set A we have elements x1, x2, x3, and in set B we have x1, y1, y2, y3, and y4. All elements in set A have a different image in set B. That means the function is 1 1. Similarly, what's onto function? A function, here is onto function. A function f from a to b is said to be onto if each element in set B has a pre-image in set A. You know it looks like quite its inverse. Here each element in set A should have a distinct image in set B. Here each element in set B should have a pre-image in set A. You just look at the example. Here set A is x1, x2, and x3, and set B is y1 and y2. Y1 is having a distinct pre-image, that is x1. Y2 is also having distinct 2 images. It doesn't matter that it consists of 1, 2, or 3, but it should have at least a pre-image. That means y2 is also having a pre-image x2 and also x1. Here codomain of, what's a codomain of function? It's simple, y1, y2. Range is range is y1 and y2. Similarly, here another example. Set is x1, x2, x3, and x4. Set B is y1, y2, y3, and y4. Y1 is having a pre-image x1, y2 is having a pre-image x2, y3 is having a pre-image x4, and y4 is having a pre-image x3. That means all elements in set B have at least a pre-image in set A. That's called 1 1. Now the bijective function is that function which is both 1 1 and onto. But this cos function, the cos function is neither onto not 1 1. It's many one and into. For that we'll be restricting its domain to here -pi to 0 or 0 to pi or pi to 2 pi, by virtue of which it will become bijective. That means it will become both 1 1 and onto, and hence its inverse will exist. The cos inverse will be a function like when we restrict the domain of cos function to 0 to pi, or any interval of -0 and 0 to pi or pi to 2 pi, and its range as -1 to 1. Hence Since its cos inverse will be having a domain of -1 and 1 and range 0 to pi, as you have went through in the previous lecture. Now here is a graph of y is equal to cos x. It's like that of sin x, like sinusoidal wave function. You can check just its range varies from -1 to 1, and it's from you just look at the graph carefully. I'm pausing the video so that you will be able to find to note it properly. And it's ranging from minus pi, and you can say -2 pi to pi, or 2 pi, that we have discussed in the previous segment. Its inverse will be like this by interchanging its x-axis and y-axis, and you will be able to find its inverse graph. I'm pausing again the video so that you will be able to note it properly. So dear students, we just mentioned certain things by restricting the domains and doing different things so that we'll be able to find the its inverse, like we did in sin and now with cos function. Similarly, here comes the third function, that is tangent function. You'll be knowing that I will be saying you that you have to went through the relations and functions, and you have to make it a good hold on that very chapter, so that you will be having a good hold on functions, because it's very much needed in this chapter. I'm again saying that it's very important to understand this function concept. Now I'm defining it in a brief manner, so that it's because of lackness of time, I'm doing it in a very brief and precise way, so that you will also understand the things properly. Now the third function is tangent function. You'll be knowing that the tangent function is not defined for odd multiples of pi by 2. What are odd multiples? It can be -1, 1, 3. That means it's not defined for. What does that mean? It's not defined for. That means at these values, the tangent function does not give us any value. For example, we'll be saying that the domain, thus, after knowing that it's not defined for the odd multiples of pi by 2, thus the domain of function tangent x is a set of all real numbers excluding 2n plus 1 pi by 2. This 2n plus 1 is an odd number. You just put any value here, give any value to n, this will turn out to be an odd number. It's odd multiple of pi by 2. That means this will become a multiple of this pi by 2. It has been excluding from the domain of tangent function. It's its domain, excluding this odd multiples of pi by 2. The tangent function is money 1 and money 1 into with its ranges are the set of real numbers. Again here the tangent function is money 1 into, but for finding its inverse we have to make it 1 1 and onto, so that we have discussed in the previous segment. You just look at the example, you will find that it's money 1 and into. Now the concept comes here. We'll be again restricting certain things here. Now if we restrict the domain of y is equal to tan x to the set of minus pi by 2 to pi by 2, that means what was the domain here? Here the domain was set of all real numbers excluding odd multiples of pi by 2, but here we are restricting its domain to minus pi by 2 to pi by 2. The function y is equal to tan x becomes 1 1 and onto with range r, hence its inverse exists. So after restricting its domain to minus pi by 2 to pi by 2, we'll be able to make it 1 1 and onto, and hence we'll be able to find the inverse. Thus the tan inverse is a function whose domain is r and range is minus pi by 2 to pi by 2. Likewise in other cases the inverse then exists. You just look at the example tan inverse x. Here after restricting the domain and codomain, we will be able to find 1 1. It's both 1 1 and onto as I have defined it. Now we will be plotting the graph for tangent function. We will be making 2 or 3 values in this function. X is equal to minus, when we will be giving a value of x minus pi by 3, y will turn out to be minus under root 3. You can yourself check the things. I have done this. You can yourself check it's right. After plotting these values, its graph comes out like this. I'm pausing the video so that you will be able to note it properly. In a similar way, after interchanging its axes, we'll be able to find its inverse. Here I'm not defining these graphs or not in detail, because we are discussing here inverse trigonometric function, and you know there is not any fast speed internet, as it's restricted to 2G, and I will not be able to upload videos of larger size. So that's why I'm just trying to explain in a very short and precise manner, so that you'll be able to put some good hold on the things. The graph of y is equal to tan inverse x, can be obtained from the graph of y is equal to tan x by interchanging its x-axis and y-axis. Similarly, In fact, if the domain of y is equal to 10x is restricted to any of the intervals, we can say we cannot. I'm not saying you like you just restrict the domain only to minus pi by 2. You can restrict it to pi by 2 or 3 pi by 2. You know, or similar in that similar manner you can restrict the domain. The function y is equal to 10x becomes 1 minus onto after restricting the domain and with range r and excluding that odd intervals of pi by 2. Yes, thus the function y is equal to 10x becomes 1 and onto with range r, and it is, hence its tan inverse will be a function with domain and r, and range would be any of the intervals of minus pi by 2 to pi by 2 or pi by 2 to 3 pi by 2. The branch with range minus pi by 2 is called principal value of the function. Why I mentioned here first minus pi by 2, it's a principal value. Principal value means it's fundamentally dependent on this. There can be other values like pi by 2 to 3 by 2, but the range minus pi by 2 to pi by 2 is called the principal value of the function tan inverse. Thank you. Dear students, I will not be discussing here about the cotangent function, cosecant function, and cot functions because these are I have discussed sine, cos, and tan, cosec, secant, cot. You will be finding by yourself. But I'm here giving you the table of all the functions about their domain and codomain. I'm pausing the video so that you will be able to note it properly. This is the function. These are the functions: sine, cos, tan, cot, secant, cosec. Domain and range. Now their inverse will be like this. By interchanging the domains and range like we did with sine, cos, and tan, rest is the case with different rest of the functions like cotangent, cosecant, and secant function. I'm pausing again here the video so that you will be able to note it. In this manner, students, we have finished the concepts of the range and domains of in these inverse functions, and how we restricted the domains and codomains of functions and found their inverses. Now after this segment we will be discussing some other important entities which will be helpful in this chapter. Thank you, and subscribe our YouTube channel.